Good morning. Welcome to another session with me, Srilekha, lecturer in mechanics, so mechanical engineering, Agraharam, Sirsila. So now I'm going to speak something about your centroid. So as you know, what is centroid? Centroid is that point at which the entire area of the body is said to be concentrated, right? So in the previous classes we have discussed centroid, center of gravity, moment of inertia, and we have found the formulae for standard sections, and we have also found we have calculated a few problems, we have solved few problems, and in this session we are going to solve further some asymmetric problems and also some non-asymmetric problems. So let us discuss. So centroid of symmetrical sections problems we are going to discuss now. So now here is a given a composite figure. So a composite figure is given that you have to find the centroid of this particular composite figure. Now, so as you know, when a problem is given, first you need to understand that problem. Here, understanding the problem means, so which kind of geometry is it and what are the dimensions of the geometry. And if it is a composite geometry, then we have to solve that into sections, right? So now, uh, given a composite figure which of this shape, and the length of the figure is given, it is 50 plus 30, and the breadth is 40. Now if I split this figure, then it can be divided into two parts. One is a rectangle or a semicircle, a rectangle, and one more is uh, a base mounted on the side of the rectangle. Now I am taking this. So for a rectangle, as you know, the centroid is L by 2 and B by 2. And for a triangle, you know that it is B by 2 and 2h by 3 or h by 3. If it is from the base, it is h by 3. So let us do this problem. So given this symmetric, it is symmetric about the x-axis, right? And when you divide this section, it can be divided into two strong things. Those are what are a rectangle and a triangle. See this. This is a rectangle of length 50, and this is of height 40. So for this, if you take the centroid of this particular rectangle or the section 1, it is L by 2 and B by 2, means 50 by 2 and 40 by 2. Now if I take this part now, so horizontally it is h by 3, and vertical it is this base by 2, right? So now let us solve this, right? So for this first rectangle, for rectangle it is 40 by 50 is the area, so L into B is the area, so 40 into 50 it will give about 2000. Next, so here the centroid is simply L by 2. Next, so it is about y-axis, so we'll take only x terms. It is symmetric about x-axis, so the y term will be coincident on both the sides. So you can simply take that as 40 by 2. It is 20. Y1 is equal to y2, that is 20. Now see, let us find only the x terms. Uh, those are x is simply L by 2 for the first one. That is simply 50 by 2, that is equal to 25. Now for the second one, and a1 x1 means, so this area 2000 into this x value, it is 25. So 2000 into 25, it is something like 50,000 square. Next, so rectangle, as you know, area of a rectangle is half BH. So base is 40 and height is 30. So 0.5 into 40 into 30. So this you'll get a value of 600. Next, so for this, as you know, let us get back to the back side one. See here. Now, x term of this particular triangle means you have to consider from the axis. So, you know, for this triangle only it is h by 3. But from the axis, if you see, from the axis, this triangle is at a distance of 50. So, 50 plus h by 3. So, that is what we have taken. It is 50 plus h by 3. So this 50 is the distance from the axis to the triangle, and this h by 3 is the centroid formula for it. So next, its area into this x coordinate. It is simply 600 into 60. That will give 36,000. Now summation of all these areas, nothing but 2000 plus 600, it will give you 2600. And some of the this moment of areas, it is 50,000 plus 36,000, it will give you 86,000. Now, so as you know, the formula for centroid is, sum of the moment of areas by sum of the areas. So you know that, so position of the centroid from the y-axis is x bar is equal to a1 x1 plus a2 x2 by a1 plus a2. Okay, so just substituting those values. So 2000 into 25 plus 600 into 60, that is by 2000 plus 600, that is equal to you'll get a value of 33.07 mm. So for the given above said figure, the centroid is located at 33.07, comma 20. Next problem. So find the centroid of a channel section given in the figure. So that's given a channel section. So whose length is 50 and whose height is 100. Now you can divide this channel section. So let us divide this channel section into definite shades. So here you can see the dotted lines. So we are dividing this particular C section into three rectangles. Okay, three rectangles. So the first rectangle is of length 50 and its breadth is 15, and the second rectangle is of length 50 and the breadth is of 15. So the leftover rectangle is of length 7, its length is 15 and breadth is 70, because 100 is the total height given, but here 15 is taken and here 15 is taken, so leftover will be 70. So here you can take ABJH is a rectangle whose dimensions are 50 by 15, and CDEK are rectangles whose values are given like this, right? So similarly, now this third one is 70 by JGKF, or JGFK is 715 by 75. So let us find this. So we are dividing this section. So this section is symmetric about x-axis. So the centroid will lie on this x-axis. So now you have to split about this y-axis. So now we have already discussed this, that the section is split into three sections. Those are 1, 2 and 3. Now A1, A2 and A3 are the areas, and X1, X2 and X3 are the distance of the distance from the y-axis to their centroids, nothing but the centroids of each section. Now we have to calculate all those from the given tabular column. Okay, so right. So the first centroid, it was, so its area was 50 by 15. So we have already discussed that we are going to make use of only the uh, distance from the y-axis, right? Now first centroid, it is 50 by 15. First at the base we have seen of channel section. So its dimensions are 50 and 15 and its area will be 750. Now as you know, for the rectangle, it can be taken as L by 2. So L by 2 means 50 by 2, it is nothing but 25. So now area, moment of area, nothing but area into perpendicular distance. That is how much it is given as 750 into 25, nothing but A into X. So 750 into 25 is 18,750. Okay, 18,750. Next comes the remaining, the vertical web type of one. That is how much. So we already discussed that 15 is left over at the top side and 15 at the bottom side. So the remaining one will be only 70. So 70 into 15. 70 into 15 will give 1050. Now distance from the y-axis is simply you can take as uh, 15. So 15 by 2 is 7.5, because we know that it is L by 2 and B by 2, right? So it is 7.5. So now area into this moment of area, it is 7.5 into 1050. 7.5 into 1050 is how much? 7875. Okay. So this is how we calculate. Now next, similarly, the last rectangle, smaller one at the top. So its value is how much? It is 50 by 15 and the area is 750. So now the x term is simply L by 2. We know that. So L by 2 means 50 by 2. It will give you 75. Next. So area into this x term is 750 into 25. It is simply 18,750. Okay. So this is how we calculate the values. Okay. Now some of these areas let us take, that is A1 plus A2 plus A3. Nothing but 750 plus 1050 plus 750. It will give you a whole sum of 2550. Okay. Now next, this 750, sum of the moment of areas. It is 18,750 plus 7,875 plus 18,750 rupees 50. So this one entirely it will give you a value of 45,375. So next, so centroid is given by x bar is equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2. Okay. So this is how we calculate the values. So it is simply sum of a1 x1 plus a2 x2. Okay. So the summation of moment of areas is 45,375 and sum of the areas is given by in this manner. Okay. So this is how we calculate the value. So you'll get 17.79 mm. So 17.79 mm can be written as 17.8 mm. Next problem. So determine the centroid of the I section. So I section is given, that is where the webs are not equal. So I section, so the web is of the length 10 and 120 is its height, whereas all the flanges are of flanges, the bottom flange is of length 200 and the height is 20. And similarly, the top flange is of length 60 and its height is 10. Now we have to calculate the centroid of the given I section. So it is as simple as it is. Only the thing which we need to do is we simply calculate the values. So we have to divide this centroid into three equal parts. Okay, so let us do that first. So first is this web. So this web is 200 by 20. So its centroid value is simply x by L by 2 and B by 2. So you can take as L by 2 is 200 by 2. It is 100. Now B by 2 means 20 by 2. It is simply 10. Okay. Next, so the vertical column. So now this other flange, bottom flange is at a distance of, the top flange is at a distance of, from here if you see this x term is simply 100 by 2 again, because this is 60 by 2 plus this distance also you have to take, right? So this is how we calculate. So first divide the section into three plane areas, that is 200, 220 and by 20 and 120 by 20 and 60 by 20. So this is the bottom flange, this is the web, and this is the top flange. Okay. Now the given section is symmetric about y-axis. So hence x lies on y axis. Okay. So given that area is 200 by 20, L into B. You know that. So it is 4000. Next, the y term, we have already calculated that it is 10. Now a into y is 4000 into 10, nothing but 40,000. Next, area is 120 by 10, that is 1200. Next, y term is 80. Now the entire value a into y is 96,000. Next, third one is 60 into 100. Sorry, here is a mistake. 60 into 100. So that will give you a value of 600. Next, the y term, y value is centroid from the x-axis is at a distance of 145. Now, this area into y term, nothing but 600 into 145 will give you a value of 87,000. Now, sum of the areas, let us take. So, 4,000 plus 1200 plus 600. It will give you a value of 58,000. Next, sum of the moment of areas. It is 40,000 plus 96,000 plus. So you will get a value of 2,23,000. Right? So 2,23,000. Next. So you know that centroid is nothing but sum of the moment of inertias by sum of the moment of areas. So let us do this. So y bar nothing but the centroid or distance from the x-axis of that particular I section is sum of the moment of areas by sum of the areas. Nothing but a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Okay, so it is nothing but 2,23,000 by 5,800. This is how we get the value 38.49. Next, determine the centroid of the angle section given. So now, given this L block or an L angle, so this section is 92 and its length is 80, while its height is 92. And given that thickness of this particular block is how much? It is simply 12, right? So now let us calculate it. So let us divide this particular angle block into two definite shapes that are nothing but two rectangles. Okay. Two rectangles. So one rectangle is of length 12, while the other rectangle uh, is of length 80 and the height of 12. Next, the one more rectangle is of length 12 and its height is of
4. Okay. Now let us take first the horizontal one. So for this it is simply L by 2. L by 2 means 80 by 2. It will get a value of 40. Next, it's B by 2 means 12 by 2. It is nothing but T. Okay. Now let us do it. So for this the x1 is 40 and y1 is 6. Next, for the next term if you take, it is simply L by 2 means it is 12 by 2, nothing but 6. 6 is the x term, whereas y term is 52, nothing but 104 by 2. Okay, so 104 by 2 you get. So this is how we will be doing it. So let us go for the centroid next calculation. Now first one, area is 80 by 12. You get 960. Now the x term is 80 by 2, it is 40. Next, a into x means area into this x term. 960 into 40, it is 38,400. Okay. So 38,400 means you will get a value. Next, y term is 12 by 2. So 12 by 2 means how much you will get the value? 6. Next, a into x means 960 into 5,760. You will get a value of 5,760. Okay. So this is how we will get this 49,920. Now let us take the summation, sum of these areas. Nothing but, so it is 1920, 960 plus 960 give you 1920. And sum of the moment of areas about y-axis is 44,160. Okay. So it will give 44,160. Next, these areas, some of the moment of areas about x-axis is 5760 plus 49,920. It will give you a value of 55,680. Okay. So this is how we need to calculate the values. Right? Next, so we know that the distance of the centroid from axis OY is is 44,160 by 1920. You get a value of 23 mm. Next, distance of the centroid from OX axis is, it is y bar equal to sum of the AY by y. You will get a value of 29,029, this much. Okay. So next, let us find the centroid of the given lamina. So you can see this shape is of different profile, different profile. So having a semicircle and having a rectangle and a triangle. So you can divide this region into three shapes, right? Okay. So one is a rectangle of length 100 and height 50. Next is a semicircle of diameter 50 or of radius this much. Okay. Now let us divide this. Next one more is a triangle of length 50 and height is also 50. As the section is given, okay, so this is not symmetric about any axis. So we need to find values of everything. Okay, from every edge you need to find. So let us take. So first the centroid is of first it is a rectangle of length 100 and the breadth is 50. Now this length comes, when length comes you need to consider the radius of the semicircle also. So given that semicircle is given that the rectangle is at a distance of 25 from the y-axis, so you need to consider this distance 25. So 25 plus L by 2, you'll get a value of 75. Okay. That will give next area into x term. It is 5000 into 75. It will give 3,75,000. Next, y term is 25. Now area into this y term will give 5000 into 25, nothing but 12 lakh, 1 lakh 25,000. Okay, this is how we calculate the values. Next, so semicircle. We know that semicircle area is pi r square by 2. Pi r square is the area of a circle, whereas for a semicircle it is pi r square by 2. Next, so x term is 4r by 3 pi. So 4r by 3 pi will give you a value of 13.4. Next, area into this x term, it is nothing but 982 into 14.4 will give you 14,140.8 mm square. Next is y term. Y term is simply d by 2. So d by 2 is 50 by 2, nothing but 25. Next a into y, nothing but 982 into 25. It will give 24,550. Okay, next third one, nothing but the rectangle. Now area of the rectangle means half BH, nothing but 1250. Next x term is 100. Next y term is 1,25,000. Ax is 1,25,000. Next y term is 66.7 because it is h by 3. Okay. Next ay is nothing but 1250 into 66.7. I think 83,375. So sum of the areas is 5,000 plus 982 plus 5,000 plus 982 plus 1250. Nothing but 7,232. Next, sum of moment of areas about y-axis is 3,75,000 plus 14,140.8 plus 1,25,000. So it is 5,14,140.8. Next, sum of moment of areas about its value is 1,25,000 plus 24,550 plus 83,000. We get 2,32,925. You know that centroid is nothing but sum of sigma ay by sigma a. So centroid can be calculated by the formula x bar is equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Similarly, y bar can be calculated by a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Now, if you substitute those values, it is 5,14,140.8 by 7232. These are the values which we have taken. It is 71.1 comma 32.2 mm. Okay, so this is how we calculate the centroid. So in today's class we have discussed various problems regarding the centroid. So first we have discussed the problems of having what we had. It was something like we have introduced the problems of. So let us go back once again. So we have calculated many number of problems, out of which the first one was a symmetric one and the second one was an asymmetric one, and so this is a symmetric about x-axis we have taken, and the next one was symmetric, which is symmetric about x-axis again, but we could easily trace out by dividing this channel section into three equal parts, right? Next we have taken uh, I section, uh, I section where it had asymmetric, which had of different sizes of flanges and web. Next, so we have equally divided the parts and we have done everything. Next we have done centroid of a angle section, right? So this is how we have calculated for today, and we have also discussed a lamina, nothing but a plane area which is of a definite shapes. So this is all for today, and tomorrow's class will be discussing about the uh, various so tomorrow we'll be discussing about the Z section and uh, of different lamina sections, and tomorrow onwards we may start the moment of inertias. Okay. So in today's class we have discussed centroid. So centroid is nothing but it is the point at which the whole area of the figure is set assumed to be concentrated in. Now the centroid of the body constituting this different areas can be given by x bar is equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3 and so on. Next, y bar is nothing but a1 y1 plus a2 y2 plus a3 plus uh, y3 by a1 plus a2 plus and a3 plus and so on. So in this manner we have discussed all the types uh, of centroids for different types of areas, and tomorrow onwards we may discuss about the parallel axis theorem and perpendicular axis theorem. So parallel axis theorem is as simple as it is. So it is simply that the moment of inertia of a plane area about any axis is equal to the sum of the moment of inertias about the centroidal axis, and the product of the area and the square of the distance between the two axes. Simply we can take that IA is equal to Ig plus AH square. Similarly, perpendicular axis theorem is if Ixx and Iyy are the moment of inertia about perpendicular sections to mutually perpendicular axis x and y, then the moment of inertia of section about the axis zz is simply Izz is equal to Ixx plus Iyy. So this is how we calculate the moment of inertias for everything. So let us discuss in tomorrow's class about all those things. Okay. So for today, it's a goodbye.